in number 9, the numerator 3x squared minus 14x plus 8 is a quadratic trinomial with a leading coefficient greater than 1. So we're going to need a crisscross and a box to factor that quadratic trinomial. So we multiply a times c, 8 times 3, that's 24. We want factors of 24 that add to equal b, which is negative 14. That would be negative 12 and negative 2. And then the first term goes in the first box, that's a 3x squared. Last term goes in the last box, that's an 8. And then the diagonal gets the values from our crisscross, negative 12 with an x and a negative 2 with an x. So then we go across each row and up and down each column looking for the GCF. So 3x squared and negative 12x have a GCF of 3x. Then negative 2 and 8 have a GCF of 2. 3x squared and negative 2x, they have an x in common, and then negative 12x and 8 have a GCF of 4. Since the diagonal is negative, these factors will both have negatives, and so the numerator factors as x minus 4 and 3x minus 2. Okay, the denominator is already linear, so x minus 4, that doesn't factor any further, and we can see that the x minus 4 will cancel from the numerator and denominator and leave us with just 3x minus 2. Okay, so that canceled factor of x minus 4 will create a hole in the graph, and we'll find the coordinate of that hole by putting that canceled factor equal to 0 and then adding 4 to both sides. We get x equals 4 as the x coordinate of our hole. Then to find the y that goes with it, we put that 4 back into our simplified form. So 3 times 4 minus 2 would be 12 minus 2, which is 10. So 4 comma 10 is where this hole is located. So we come over here to 4 and then up to 10, and we'll go ahead and put an open circle on the graph there to represent that hole. Okay, then the vertical asymptote equation, there can't be a vertical asymptote unless there's a denominator, right? In our simplified form, there is no denominator. This is just a straight line, y equals 3x minus 2. And so there is no vertical asymptote. Okay, to find any zeros, we set the numerator equal to 0, and so that would be 3x minus 2 equals 0. We add 2 to both sides, and we have 3x equals 2. Divide both sides by 3, and x is equal to 2/3. So 2/3 comma 0 would be the coordinate of our x-intercept. So we come over here to approximately 2/3 and put a closed circle on the graph. To find the y-intercept, we substitute 0 for x in the simplified form. So we have 3 times 0 minus 2, and then that is equal to negative 2. So 0, negative 2 is going to be the coordinate of the y-intercept. Okay, then equation of horizontal or oblique asymptote. Remember, Bobo Botan eats DC. If it's bigger on top, none, and this denominator here is a 1, so that's degree 0 on the bottom, degree 1 on top, so that's bigger on top. So there is none, no horizontal asymptote. And when we go to sketch this graph, we're going to need some extra points. So if we put in a 1 for the x, then 3 times 1 is 3 minus 2 is 1. So the point 1 comma 1 is there. Okay, if I put in 3 for my x, 3 times 3 is 9, minus 2 is 7. So 3 comma 7 is on this graph, and we can see that this is a linear function, so its y-intercept is -2, and then we can use that slope of 3 and get as many points as we want. So up 1, 2, 3 over 1, up 1, 2, 3 over 1, right, and so on, and then we can connect those dots, and that would be the graph of the rational function. So this f of x makes a line with a hole in it, and that hole is going to cause a break in the domain and the range. So domain is -infinity until that hole, which has an x of 4, union, and then 4 to +infinity. The range is -infinity up to this y value of the hole at 10, union, and then 10 to +infinity.